Hey everyone, today we are looking at an Alesis Quadraverb effects processor. This unit I purchased from eBay. It was a not working unit, so I got it extremely cheap. I think I only paid $10 for it, if I recall, plus a little bit for shipping. It wasn't very much. I've had this sitting around here for a while, I just haven't had time to look at it. So now that I have time, I want to see if it is actually repairable, and at the same time take a look inside it, see how it works, see what's actually running it. This is, incidentally, one of my favorite effects processors. I'll talk about that a little bit more later. With this, there's a few things I noticed in the auction. The first thing from the pictures that was listed with it was that I could tell that somebody's had a go at it. On the back here, there's little plastic nuts that are supposed to connect to these quarter-inch connectors that actually hold it in place. They're all gone. So somebody has at least attempted to repair this, took the main board out, and for whatever reason put it back together, and didn't even bother installing those nuts on. So I don't know the full history of this. I don't know who's looked at it or for what reasons. Purchasing this as well, I wasn't even sure if it would be repairable, but being so cheap, it wouldn't be that big of a loss if it wasn't. It'd still be fun to tear down, take apart, without having to worry about damaging my working one. This did not come with a AC adapter. It needs 9-volt AC. Unfortunately, Alesis has this little proprietary 4-pin connector on the back, but I have another power supply for my working Quadraverb, so I'm going to plan on just using that to power this up. The other thing I noticed once I received it was that this, I couldn't tell from the pictures, but now that I have it in my possession, it's noticeable, is that this top cover is actually on, looks like it's on upside down. The paint on this is kind of a textured paint. It's just a black textured, I don't know what you want to call it, I don't know if it's powder coated or what, but the top is perfectly smooth, and it doesn't match the outer case. So it looks like whoever had taken this apart put the lid back on upside down. So if you're looking at gear to buy broken for repair, just some things to look out for to kind of get yourself familiar with the device itself, to make an assumption if it is repairable or not. Especially if you're spending a little bit more money on this gear. Granted, like I said, this is so cheap, I don't care. But if you were spending more money on a piece of gear, it's better to buy something not working from the original owner, where nobody's really taken a real good shot at trying to repair it, versus a unit like this, where somebody has obviously been inside it, attempted to repair it, or deemed it unrepairable or not economical to repair for whatever various reason. There's some ASICs in here that are proprietary that if they're bad, you're not going to find replacements for it other than from another replacement unit. So the Alesis Quadraverb came out in 1989, and they made it up until the mid-90s. I'm not exactly sure what year they stopped production of it, but there was a lot of revisions of this, actual hardware revisions on the inside. The design changed quite a bit. The filtering on the input changed. The actual filtering on the output of the digital analog converter changed. There was some actual design changes to the board itself. Revisions went from A all the way up to G or H, I believe. There might be higher ones than that. I do have a date code on the back from at least the manufacturing, though, stating that it was made, or at least the quality control sticker is 4/24/89. So this is a very early unit. There was actually a lot of modifications that Alesis recommended to make to these units, especially the earlier ones, to solve some bugs and other issues with them through their life cycle. So while I'm inside, I'll be able to take a look at that and see if any of those modifications have been made. So the Quadraverb is one of my favorite effects processors, as I mentioned earlier. It has just a really, really great sound. The reverb is outstanding on it. I've always enjoyed the reverb from this unit. The rotary speaker simulation is one of the best Leslie's I've heard. I really, really like it. It's very raw and very coarse, not in a bad way, but through a good organ patch from a synth, it just sounds really, really, really good. And it's powerful as well. This unit can do, you could be in the Quadraverb, you can actually put 4 different effects in a chain through this unit if you program it correctly. A lot of the built-in presets have that, have set up presets anyway that do this chain for just quick use. And the presets in here are also very good. A lot of the presets themselves are very, very useful. One of the other features I really like about it is it has a bypass switch, so you can easily bypass it here at the effects processor instead of having to worry about bypassing it back from your mixer or wherever else. The buttons are pressure sensitive too, so the harder you press them, the faster they scroll. It's nice when you're scrolling through your presets trying to get to where you want it. Before I open it up, I at least want to power it on and see what it's doing. I'm just curious if it works at all, or if it does some other weird issue. Maybe it doesn't power on. I don't know. The auction just said doesn't work. That was pretty much the extent of the description. So I got it hooked up to power. We'll turn it on. Got some lights on the input side kind of flickering there, which is unusual. Nothing on the display. All these lights are supposed to light up too on the buttons. I don't see anything there. Just cycle here a few times. And all those lights are flickering on the input side there, which is yeah, so pretty much nothing. Alright, let's take a look inside. And there we are. So, looks different from what I remember, because I've opened up my other one, and granted it's been a while since I have, but it does look a little bit different. So, because the transformer itself is external in your little power pack, the transformer inside there, and it's AC coming in, you just have a simple DC supply in here. So, your rectifier, handful of caps on the filtering side. I'm curious to know if any of those are leaking. Lithium battery in there, we can test that. So we'll start with the power supply and look at voltages. They're all labeled here on the side. You can see plus 12, plus 5, minus 12. So this is probably a heat sink to those regulators. I'll pull this plate off and then we'll measure voltages with the powered up start there. Yeah, that's just a little heat sink. And some standoffs here on a couple of the regulators just to sink some heat off of those guys. Yeah. EEPROM in here too. There was different software revisions on the EEPROM as well. This is 1.03 from 3.13.89. Alright, powered up. We'll start with the 12 volt regulator. Let's get to ground, should be plus 12. 11.81. 11.8, close enough. With the 5 volt regulator, nothing. That's a good sign. And the 12 volt regulator, and negative 12 I should say, we got negative 12. There's no 5 volts. Got 9 volts in. Got nothing out. So, the question with that is the regulator bad, or is something sinking the plus 5 volt down? The former would be better, the latter could be troublesome. I think I may pull a couple chips and just see if anything is sinking that 5 volts down before I proceed any further. Actually, before I even do that, I'm just going to cut the output leg of this 5 volt regulator. That'll tell me right away. So I can measure the regulator out of circuit at that point. Alright, so we'll power it back up. Meter over so you can see. Okay, so something's sinking that 5 volt line down. So the next step will be to figure out what that is. So we'll start dividing, conquering the board, pulling some chips out, unhooking some cables, and seeing if we can determine what the source is. I'm going to start just with this front panel. There's just 2 cables right here that should just pop off. I gotta solder that pin back on though to boot that circuit back. Alright, got the 5 volts back into the circuit. Measuring the 5 volts. Got nothing still. Alright, so nothing on that front panel connector. I can't imagine it's that. That's just the audio pathway for the knobs there. Could be the LCD maybe. I'll plug in just to see. No difference. Alright, so plug the parts that I unplugged back in, at least for that. I'll leave the front off there. That's for LCD. So, I guess we might as well take a little bit closer look on the internals here before I start pulling chips. So here's a look at the inside. Here's the 3 regulators I was talking about over here. This is the 5-volt regulator, which pin I cut and soldered back on just to test to see if the problem was a regulator or if something was actually syncing it, which we determined something is syncing the actual output there. The main processor is a, let's see, it's a old Signetics chip, Intel 1980. It's a 80C31. I'll have to look up the data sheet on that, actual micro. But aside with that, we've got our ROM, most likely RAM. And then this is the main DSP ASIC on the actual board here. It's covered with stickers to actually see what the part number is, but that will be an Alesis branded part, specifically for the Quadraverb that I'm sure they had custom made. Here's the RAM that goes along with that DSP. The RAM is critical in handling the actual algorithms in terms of the delay and reverb and everything else. It's either SRAM or DRAM. I'll have to look those up. I'm not sure offhand. And then this is probably our DAC. Of course, I'll have to clean that off to see. I'm not sure what the DAC is in here. I think it's a Burr Brown. I'll have to look it up to be sure. So that's our DAC. In terms of analog digital converter, they're doing a successive approximation type analog digital conversion based on registers within the actual DSP itself. Very similar to how Lexicon handled the conversion in their LXP15. Besides that, we have our filtering on the output side. So we have the filtering necessary for the digital analog conversion to remove all the high frequency noise, which then passes to the output connectors back here. I believe these are the inputs. Actually, these are the inputs, these are the outputs. Besides that, there's some glue logic and some other logic in here just to run the display and things like this. Somewhere in here there's going to be some analog multiplexers. I believe that's these 4053s. I think they're analog switches basically for the digital analog conversion, because this is chopping between the left and right channel. It's not actually a stereo DAC, it's a mono DAC, and they switch back and forth between the left and right channel at a very high frequency to produce stereo output from a single channel DAC, which is the way a lot of the older CD players and a lot of the older conversion gear worked back from the 80s and 90s. It was cheaper to do that way. That's why they did it. Later on, when DAC prices went down, you could get really high quality DACs for less money. They started just making stereo DACs, and they were pretty impressive at the time. This, I believe, is a 16-bit DAC too. Alright, so next I'm just going to start pulling some chips out of here and powering it up and seeing if I get my 5-volt back. Based on that, I can determine if one of these is bad, and that will be the cause of the 5-volt line dropping down. I'm hoping it's not this, this, or this. Maybe it's RAM that's bad. Maybe I'll start with those first. I'm not sure. I could probably source that pretty easily. Same with that RAM chip there. The ROM, you can buy the ROMs, but the point is I don't really want to put any money into this if I don't have to. And the sellers on eBay are... You know what though? Actually, I don't even need to. I can burn another one myself. I'll just pull the ROM out of another Quadraverb, so I don't care if that's actually bad. The DA converters, depending on what it is, it could be easier, it could be expensive. I gotta get the rest of that sticker off there to see what it is. Again, I think it's a Burr Brown. If it's an older one, you can usually find them for pretty cheap. These were state-of-the-art back in the day. They're still good today, but they're not as good as modern DACs. So a lot of people aren't using them for, obviously are not using them for new designs, but part sources, they still usually want a premium on them because they're Burr Brown. And then depending on the RAM is, it's probably easy to source. But alright, I'll start pulling chips. Start with the EEPROM. Like I said, I really don't care if this is bad. I can just burn a new one. I'm gonna hardwire my meter up to the pinout on there just so I can easily see if there is a difference or not. Okay, I got my meters wired up to that regulator, so I can just power it on now and quickly see if it made a difference, which EEPROM made no difference. Alright, let's try the RAM chip next. I took a picture of this, so I'm not worried about the orientation of the chips. I'll remember how they all go back in when I put it back together. U18 out, no difference. Alright, let's try the DAC. Powering up. Nope, not the DAC. Just leave it out. Main microprocessor. That's not the case, but alright, main micro out. No difference. Alright, that's good. There's not much left. I'm really hoping it's not that main ASIC. I'll pull the RAM next. Alright. RAM is out. Power up. No difference. That's a PLCC, the main DSP there. It used to have a puller for those somewhere. I don't know where it's at. Without one, it's kind of dicey to pull. I prefer not to do it if I don't have to. So I'm not going to pull that yet. I don't want to. It's risky for me to do so without the right tool. I'm going to check a few other things in this board before I do so. I want to take a look at these caps. It's possible as one of them could be driving or pulling the 5-volt line down. Also, this board is covered with tantalums, little blue caps here. I've seen a lot of gear where those go bad over time and they actually short, which could drop your 5-volt line down. So I might look at those next. To troubleshoot those, usually it's a little bit more tricky. The best way I found is you actually divide and conquer. So you follow the traces on the board and you just start breaking the 5-volt pathway up into the various spots until you get your 5 volts back. Then you can kind of determine what area of the board has the problem. And based on that, you can usually isolate it to one of those tantalums actually causing the short and bringing that 5-volt line down. So I think I'm going to try that next before I pull any more chips out. I have the main board removed from the Quadraverb. And based on this design, I can actually debug this while it's out of the case. Nothing in the case actually will prevent me from working on the problem here. So I got my power connector and I've got my switch to turn it on and off. I'm leaving all the chips I pulled off because there's no reason to keep them in at this point. They don't help at all for me debugging the situation, which is why do I not have a 5-volt rail. So as I mentioned before, after just pulling the chips, which is just an easy check, just to make sure that none of them are pulling it down, which in this case they weren't. Although there's looks like an op amp there. I should try pulling that just to make sure as well. The next thing I'm going to tackle is these tantalum capacitors for all the decoupling capacitors on the 5-volt side. These will all be on the 5-volt logic because they're all tied to positive and negative on the chips for decoupling across them. And like I said, I've seen gear in the past where these have caused problems, especially when they get old. Usually when they fail, they short, and that would explain why I'm not getting any 5-volt power on the 5-volt rail. Secondly, I was kind of looking at the power supply here, and first thing you'll note is it gets hot. You see the board's a little black in the bottom from those regulators. Now, is that partially because this 5-volt regulator has been, sinking a ton of current due to a short? Possibly, but this 12-volt regulator looks kind of black next to it as well, and the 12-volt rail is there, or negative 12 I should say, so I know that's not a problem. With this regulator being hot, these two caps right next to it look a little cooked. The 4.7 microfarad caps, you can usually tell because the tops start to shrink back a little bit when they get hot, and they just kind of have a brownish look to them. And the proximity to that regulator, I mean, they're almost touching the thing, they're so close. So, and actually, look at this. C70 here. Some light in there. Little pencil. That's a tantalum cap. And that is toasty. I might cut that out of circuit right now and just see what's up with there. What I was saying with this though too is these caps, these I'll definitely replace just because, these will probably replace anyway just because they're old. They're Daewoo branded, 1000 microfarad, 85C rated, nothing special. So I'll put some nice Panasonics in there, and I'll probably do the same for these other 4 caps over here. There's no reason to not to at this point since I have the board out and I know I have these caps available. considering that I'm able to solve this problem, of course. So I'm going to try cutting this cap first. Remove that from circuit. See if that's actually what's driving this down. Well, actually, I just broke it in half, so it's removed from circuit. Let's check now. So I'm getting 3K now between +5 and ground. I wasn't getting that before. It was like 7 ohms. Let me get my power this guy back up. Put this in frame here. 1,000 volts, not ohms. Huh, you got 5 volts back. Wonder if that was all the problem was. Alright, I'm going to throw this back together real quick, throw it back in the chassis, put all the chips back in, and just see if it functions. I'll be curious to see if that's all the problem was. This will at least tell me if I need to replace that and possibly do some other caps on the board. Alright, all reassembled. For now, just got a couple screws holding it together. About to power it back up to see what we've got. And haha, look at that. It works. Yeah, I might have to reset it. Let me actually do that. So power's on. Kind of locks up after that though. So does it need a hard reset? Or is it strictly just because there's ripple and other issues in the power supply causing it to soft lock like this? It's powering up though. Alright, so the next step is, for me, is I'm going to address that power supply. I'm going to get all those caps replaced and replace that dead tantalum that's cooked, and we will go from there. Okay, digging through parts bins. I've got enough to fix this right now to see if it at least resolves the error. I'm going to have to order some parts though. So I've got plenty of surface mount tantalum 0.1 microfarad caps, but I don't have any through hole. So I'm going to stick a 0.1 ceramic in there for now, which will be good enough. For the 4.7s, I've got 2 nice Rubicons. They're only 85C rated though, not 105. So I'm going to order some 105C rated caps. I'll stick those in for now too. For the 4 caps back here, they're 470 at 25 volt. So I've got some nice Panasonic 470 at 25 volt radials, 105C rated. So I got plenty of those. A little bit different form factor, but they're short enough where they'll still clear the lid, which is fine. These 4 are 1000 at 16 volt. I don't have any of that value right now, so I will leave them. I'll order them though, and I'll replace those as well. So I'll work on replacing all those now. I like to mark the polarities in the board just so when the caps fall out I don't have to worry about remembering how they were aligned in there. You can see how cooked these capacitors are. They're just not good. I'm going to clean the board up a little bit too, just in the event that they have been leaking some electrolyte. I'm leaving a little bit extra lead on these two caps, just so I can kind of bend them away from that regulator a little bit, just so they're not so close to it. I just hate designs when they put regulators that close to, or capacitors that close to regulators. It's just, spread them out a little bit. Capacitors are always a failure point, and heating them up is never a good thing. So new 0.1 microfarad and two new 4.7s. Next I will handle these four caps. They don't look too bad, but I mean, at this point, they're almost 30 years old. Why not replace them? Alright, so still got to do these four. I don't have them now, I got to order them. I'm going to replace these when I get them. But besides that, I think we're ready to power it up. Some interesting bodge work over here on the corner. It's kind of fun. I tested this lithium battery too. It's good. It doesn't need to be replaced, so I will leave it alone. There's a lot more caps too on the output side over here. A lot of 4.7s. I mean, they're just as old. I mean, to be fair, this solved the power problem. It doesn't tell me if it works. So before I do anything else, I'm going to power it up, see if it actually functions without locking up, hard reset it if I need to, and then we'll go from there. Okay. Resuming power. Back to where we were. No response from the buttons though. Let me look up the reset procedure. Okay, the reset procedure for this is to hold the program and bypass buttons down while you power it on, so I will do that now. Assuming I hold them. Alright, I'm on the program screen, so I got further than I did before. And I can scroll through my programs now, which is good. It seems to be functioning. Contrast in this display isn't very good, but that looks good anyway. So next test will really be to actually, you can see here the pot's a little dirty. See the noise being generated from the input pot. They actually pass the analog audio through this. This isn't a digital encoder that's actually doing a digital volume control. It's actually analog data through there. So when these get scratchy, you see noise and it picks it up on the actual unit itself, causing the issues that you see here. So I'll have to clean those pots. But I think it's working. So I'm going to get an audio source and pass it through here and see if it's functioning. But this is looking very promising. So I have my Quadraverb hooked up through my JV80 here, and I'm just feeding it to my bench computer here because I've got a stereo set of speakers hooked up to that. It's gonna sound terrible, but you can at least verify. At least I can verify it's working, which it is, which is really nice. So. So that's your Leslie, which I love. We'll go down to just some basic reverb. So large room, medium hall, and then we'll go back to just a standard piano. Bypassing it. With it in place. I actually have some reverb on my synth that I need to remove. Okay, so here's dry, and here's with the reverb. So it's working, which is awesome. Alright, next I've got the program set to Concert Hall 1, which is just a very, very heavy reverb. Again, this is wet going through the Quadraverb. Bypass is just dry. So with that, it's gonna sound terrible because I'm playing it through little 4-inch speakers on my computer. I've got the gain set way high in it because I'm feeding the audio actually into the mic jack on the sound card of my computer. Plus you're listening to it over YouTube, over the microphone from my recorder here. It's just not gonna sound good. This unit though does sound very, very well. There's plenty of other reviews on YouTube of people demoing all the patches and sounds on there. It is a very, very, still to this day, good sounding reverb unit, or effects processor for that matter. One last thing I wanted to check on the Quadraverb is actually what digital to analog converter they're using. So whatever sticker that was on there pretty well. I'm having hard time getting it off, but if you just get it wet with some rubbing alcohol, you can see it is a Burr Brown PCM 54. That is a 16-bit mono DAC. It is the same DAC actually that was used in the Lexicon LXP15. So they're getting stereo out of this. It's a parallel input DAC too, not serial. So they're driving it directly parallel data off the DSP to the DAC, and then the analog side of that's coming off, and they're doing some clever switching back and forth, and then filtering at the end to get the stereo signal out of it, both left-right channels from a single DAC, which is pretty interesting. I was curious to see any differences between this Quadraverb, which I just repaired, versus my other one that I've had for a little while now. This one's actually dated 91, so it's a 2 years later model than this one. So not the latest, but slightly later. I took the cover off just to compare to see what the differences were inside, and they are pretty similar, although there are some minor differences. The first difference I noticed was the filtering over on this side. So they completely changed the filtering. I'm not sure if it's on the input side or the output side in terms of the anti-aliasing filter or the low-pass filter for the digital analog converter, but the filtering section is different. Other than that, the design is pretty much the same. They did replace all these tantalum caps to standard ceramics, which is what basically I replaced the faulty one on this one with anyway. And then the capacitors. They went from using the Daewoo caps to actual Nippon Chemicon capacitors in this model. So I don't know if that was something they had noticed was a problem with the caps they had and went to a higher quality one, or if that was just a purchasing decision. I'm not entirely sure. Besides that, all the other components are pretty much spec the same. It's got the same CPU. I'm not going to bother pulling the stickers off there, but I'm assuming it's the exact same silicon for their DSP, which actually has even though it's branded Alesis, it has a Harris logo on it. So Harris Semiconductor must have been the actual one that was fabricating these chips for Alesis. In regards to the power supply cable for this, what I thought was a proprietary connector actually isn't. Upon closer examination of it, it looks like a DIN connector. In this case, it's a 4-pin DIN connector. Comparing it to a MIDI cable, which is a 5-pin, you can see they're roughly the same size, except for the pin configuration is different. Checking in DigiKey, and yes, this is a DigiKey printed paper catalog. I still keep it around for connectors and things like this because finding it with the online parametric search is a pain. Being able to just pull the manual out or pull the catalog out and just look at pictures to see what you're looking for. It makes things so much easier. So even though this is like 10 years old, a lot of the part numbers actually still exist and are the same, so it is still useful. Anyway, 4-position circular DIN connector is all that power supply cable is. So I'm going to order one of those from DigiKey, and that way I can just make my own 9-volt AC power cable instead of having to source the original Alesis one. So I hope you enjoyed this repair video for the Alesis Quadraverb. I may make another video going into a little bit more detail onto how exactly the digital signal processing on this thing works. It is pretty interesting. So I hope you enjoyed, and thanks for watching.